The Joy of Functional Game Dev, Project 1, Episode 5. Hello again, everyone, and let's pick up where we left off. I have the GitHub branch for end of episode 4, start of episode 5. V 0.4.1. 0.4 was the one where I hadn't figured out that I did width and height wrong. So I quickly remedied that, and you probably saw the super quick thing. Oh, hey, I figured out what I did. So this is what I did. And so here's where we start. There's a link down below. And then let's go over to Trello and see where we're at. And at the moment, I've got done in quotes. So we've got the avatar smiley face. Yes. We've got it getting the $sign. Yes. We've got show score. And I want to make sure that in showing the score, it will go all the way up to 10. So we're going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so great. Alright, it does do it correctly with multiple characters, doesn't overwrite itself. One of the things we will want to take care of pretty readily is the fact that it's super tiny. In fact, who knows if you can even see it in the YouTube video. But we will take a look at that. I started my timer, and let's move it along. Actually, you know what? I don't need that. It tells me right there, as long as I can keep that up. Alright, so I'm going to know when my time's up. So neat. Alright, so back to Trello. And one thing, we don't need that anymore. We want to show the score, which is done. We got it showing score. We want a 60-second game timer, and we want to we'll start putting more, so we need a score label, and we want a timer label on easier to see score and time. We probably want to just get the rudiments of game state into it, because there's a. We'll talk in a minute about meta state and how today we're going to wind up with a discriminated union, and we'll leave it at that. And so let's say we want a score label, timer label, easier to see score time, rudiments of game state. We'll stretch that. If we get to that, then that's cool, but so far, getting one or two things. It's early on, so it takes a bit, and things get done at a more accelerated pace a bit later. So, actually, we're going to change our labels. So if we're done with something, it is squee. Yeah, labels squee. That's 3 E's in squee. We go it's done. And we might have to revisit some of them later, but that's okay. So yeah, okay. Score label, time label, easier to see score time, and a 60-second game timer. So, go. And that'll be what we do today. Alright. First, let's go with a bigger I think I want to have a width and a height. I think I want this. So my width and height of the draw letters, how big do I want the draw letter? So that's going to be 0. That's going to be width. It's going to be width times 2. Well, actually, really, 1, 2, 3, 5, 6, 8, 8. After typing comes 8. Alright, so let the number be that, and this is going to look kind of weird. Times W. Well, we don't need to do that just yet. So X and Y, so there's number, so destination. There. We're going to use width and height here. Width and height. As well as, well, that's destination width and destination height. So let's actually specify destination width, destination height. Destination width, destination height. And we'll still use that because that's still hard-coded in there at the moment, but we will fix it. It's saying, hey, yo, dude, I got no idea how we're going to go about this, and draw score XY. We'll put some put the destination with destination height here too, because we want to pass that up. You want to get that as far away as we can. But when we do that, we get the destination with destination height. So that's all fine there. And then when we're drawing the game, that's the start, and the destination width, destination height. Let's start with a 16 by 16, and we're going to see if we doubled it. And this is the first phase of being independent of everything. So, yep, there we are. Boink. Oop, didn't work. So it doesn't work. So, but you see, it's number. Here we are, number times 8. So it's doing the right thing. All right, let's go. Try that again. Becomes 1. And you can see, I'm going to zoom it in a little bit more. Let's go with 32 by 32 because this will really illustrate the kind of little artifacting problem that I'm having, and we'll have to deal with this a little later. You can see on the 0, see on the 1 even better, there's that little bit on the edge that's part of the 2. And it's ugly, and due to the fact that it's zooming in so much. And that's just textures and rendering. I mean, it's good enough for now, because we just need to get the idea, but for a finished little product, this is no good. Yeah, you can see the artifacting is just awful. How do we fix it? Tune in another day. But for now, we're going to go 24 by 24, because I think that's good enough. Maybe I can leave it 32 by 32. I mean, really, what difference does it make? Or maybe I can go 36, 36. Because we've got, up to the calculator. So we got 1,720. There's that. And in 60 seconds, how many else really gonna get? Well, that divides by 28, I know. That also divides by 40. Does it divide by 36? Well, probably not. 36, no. Divide by 40, divide by 28. 28 is just an awful number to work with, but let's go. 28 by 28. And that way we can have exactly 10 characters. And there we have it. Okay, swell. Moving along. Yeah, one of these. This is hard coding. It's bad to hard code, but when you're prototyping, hard coding is, well, it's just part of what you do. Thing right here, this right here is a nice function where we're not doing all the hard coding. And so this is a nice reusable function, although it is bound to a texture ID. But we would change that. We'd make that /t, and that would be, and then that would be more reusable. But we're just drawing stuff on the screen. So, and we now have the ability to draw a letter. Well, it's really draw a digit. Or, let's be more accurate. And so now we have the ability to know that we're drawing a digit. So we got a board state, and my board state is where are you? All right, we're gonna add a timer, and the timer. There's a couple of different ways you can do it. You can say, hey, the game is, because we do have we get the update interval. Let's go over to that. So we get the update interval. Where's that? Where's my game? So whenever we update, we get a delta, and that delta is be easier if we look at the game. So update. So the game updater takes a game time. Now, okay, we're going to look up what is mono game time. What is that? Here's a game time. So, what is a game time? What are you? Game time dot total elapsed time. Oh, I think, okay. How about we look at the XNA? XNA game time. What are you? Game time class. What is it you do? It is a, okay, game time members. The amount of time elapsed since the last update. Well, what type are you? It is a time span. Okay, time span we can live with. So we can either deal with and time span. We'll just go MSDN. The n time span. The time span. It's a structure, and you can get things like how many seconds there are. And you have things like total seconds, gets the value expressed in whole and fractional seconds. Total seconds. So, well, we can do this. So get elapsed time. So the time span get elapsed time is something we can. So in our something we can work with. Time span is something that we can easily work with. So in our board state, we can deal with it as a time span, and we either decide time left or time remaining. Go time remaining, which is a time span. Are we up? And it just doesn't like it. Time remaining and time remaining equals new time span. And what kind of units do we have? Hours, minutes, seconds. Okay, so hours, minutes, seconds. We got 0, 60. Oh, no, 0, 0, 60. That should give us, that's how much time we have remaining. And then, we also have let remove time, or let decrease time. And there's the delta, and that'll be, well, that's fine. That's fine for it to be at game time. And board state equals decrease time. So we're going to go board state with time remaining. Board state dot time remaining minus delta dot get game time it doesn't like. And with F-sharp Power Tool, which I kind of highly recommend, it'll give you the okay, bring that in. To other times that I've been not using F-sharp Power Tools, it is a bit more challenging. Like, oh, okay, go find where that thing is. But so yeah, they're making wonderful new tools. So then decrease time, and which means when the game is happening. So when I update the game, update that decrease time delta. Where's it? Quick action build. Oh, there we go. So it's going to decrease the time by the delta and save the board state. Of course, in order for us to draw, let's draw time. We'll also do 28 by 28 at board state.board columns, and there's 6. And again, we got to get something done here. I want board state time remaining. We'll call it draw seconds, because that's how we want to do that. So let's draw seconds. Let draw seconds. Destination width, destination height, X, Y. First say time remaining. It's a time span. Texture, and then all of that stuff. Up, and we are running over, but let's finish this stuff up. Gonna draw. Well, it's similar to this, which automatically bothers me. So we got, rather than that, it's time span. Of course, we're going to have to tell it that it's a time span. Total seconds. Make that an int. And draw the digit. Is that right? That is right. So now we're drawing the seconds, and those should go down. And let's quick see what happens, and then we're going to go to a special segment. 8, 7. Looks like it's working. So we now have a timer going down, and now we have to talk about something cool. So take it away. The F-sharp operators of the day are the bitwise operators: bitwise OR, bitwise and bitwise exclusive OR. Today we're going to talk very briefly about the bitwise operators in F sharp. When I now, I don't typically have a need for bitwise operators so much anymore as I did once upon a time. But from time to time, I still do need them because sometimes I wind up doing something like this, where I'm going to encode ESAT door. I'm going to have my doors. I'm going to have 4 of them: north, east, south, west, and they're going to be bitwise. They're going to be powers of 2. Now, so you have that. So let add north door equals, if we are naive and say, well, we're just adding them together, we're say door plus north door, we'll very quickly find let wrong equal north door add north door. And we're going to find that it's a 2, which is really east door, and that's really not what we want. So what we want is, when we're adding a door, when we're adding the north door, we need to do a bitwise operator, so we need to do an AND. But in C and most of the C-like languages, a single ampersand means AND. And this says, no. It tries to help you. It says, oh, you must be thinking of the Boolean operator, and then you can put that in there, and it immediately goes, yeah, I don't know. So it's assuming now that door is a bool and north door is a bool, and north door is not a bool. And the time that I needed to use this, I ran around for quite some time. It is 3. But actually, it's not even and that I want to use. I want to use or. So the add north door, whenever I have, so let right equal north door add north door. It'll turn out right. And similarly, if you need to let check north door to my door equals, well, I'm going to have to compound this, but door and north door, and I don't care what the number is, greater than 0. And similarly, if I want to toggle equals door, we're going to choose the door, north door. So yeah, then I come in, and this will cause it to, if it's there, make it 0. If it's not there, make it 1. So it'll make it blink. So toggle north door twice will cause the restoration of your original state. It's as simple as that, but just remember, for those rare times when you need a bitwise operator, it is 3. In most languages, or at least the ones derived from C, bitwise uses 1 of whatever symbol. Booleans use 2 of whatever symbol. In F sharp, bitwise uses 3 of whatever symbol, but Boolean still uses 2. Hey, welcome back, and we're now going to well, let's start it out at a little bit less, but let me show you what would go on here. Because we go to the board state, and the initial state is rather than 60, let's say 6. At the moment, it's not doing anything. It's just gonna decrease and count down 5, 4, 3, 1. That 0 there is the initial 0 there is misleading. It's because it can't find a character. It's going negative. So what we need to do, first put it back to 60. We need to go into a state where we're no longer responding to input if we are, and that's actually this stuff. So we need to have different states where different input is happening. You can have like a title screen, you can have a help screen, you can have an option screen. The screen where you are playing the game, which is the one screen that we've been working on so far, as well as the your game is over, and so we got to get it, and we're going to put this stuff over here. And to do that, we're going to do a discriminated union type game state equals. We're going to have a play state, a board state, and we're going to have a game over state also of board state. But we're not going to we're going to just leave it frozen. So now instead of, it's no longer board state that we care about. We now have whole lots of things are going to change right now. So there's actually game state. You'll see, and it'll all make sense in a second. Let mutable private game state equal. Actually, we can leave that. KU. Control KU. And that's gonna game or play state. So we're gonna initialize our game state, which is now a game state, to what that is, and send it into the play state. So load board state no longer makes sense. It's gonna be game state and game state. And we also don't have that as our variable anymore. But now we've undoubtedly made a bunch of things mad. And let's find it. So save board state, not defined. Load game state. Save game state. And this is the kind of thing you want to do if you have a board state. If you don't, you want to do other things. So we're going to have a let update play state delta equals. We're going to grab that because this is what's going to happen, and we're going to say we're going to have the game state. It's actually going to be a board state. Board state. So we load the game state, we save the game state, and in between that we match we dispatch it. So let game state equal load game state match. Actually, nope, we can do it this way. Let match load game state with there's play state. Play state board state, and do update play state delta and game over state. Is it game over state? Already, I don't remember. It's game over state. We'll have a capital O in game over. Game over state, board state. Board state state, game over state, delta. We're going to say let update game over state, delta board state equals. Now at the moment we're just going to not do anything to it. We're just going to take board state and add it to game over state and return that. Of course it is up. We didn't build. We did not build. And so it's a little angry with us. X here. Take board state. Do those things to it. And then we return it as a, so it returns a game state. So in both of these cases, that's that, and then it's basically a switchboard. And those are the two different functions depending on which state we're in. Now, decrease time delta, and yeah, it stays in play state currently, but not for much longer. So we need, so we're going to go draw, let draw play state, delta, and these other things. And we're going to do switch load board state. Not switch. It's not switch. It's called match. Stupid C# accent. With play state board state game over state board state. That's what I want to do here. X. Board state. What I want to do here is that. Sort of. Not entirely. And then. Yeah, no, it's unit. It draws to unit. It returns me some nothing. So draw play state is the delta and board state and board state textures sprite batch. Suppose at the moment the game over state can draw the same exact thing, because that's totally cool. Load board state with, it's not load board state, it's load game state. Silly me. So now we've got a switchboard for drawing and updating. The one thing that we do not have is how to end it. So we update the play state. So like we're going to say let new board state equal that, and if new board state dot time remaining dot total seconds less than or equal to 0, then else. So if we've run out of time, we return new board state game over state. Otherwise, it's new board state play state. So now we should, you know, you don't have any. There's a whole lot left to do, but at this point, we will decrease the amount of time that we have to about 10 seconds instead. So now after provided we build, can we build? Nope, it's a failure. What did I miss? Expression was supposed to have type float. Brought to you by the symbol period. Sometimes in your life you just need some punctuation. So now we build, and let's see what happens. So we have 10 seconds. After 10 seconds, it should freeze me. It works. Okay, and the game's over. Well, that's a fine thing. Alright. We have, at this point, a timer. It goes down. We have a score accumulator. It goes up. One thing we could certainly do is see how well can we do in 60 actual seconds with controls the way they are. And go. Going as fast as I can. Unfortunately, I don't have a keyboard hold down. You have to actually press the key for each movement that you go. I may just make a key down, and then if it's down, then go in that direction. Because that's kind of annoying. Unfortunately, though, it is locked at the frame rate. Because if you have, and we'll have to fix that part next, or pretty soon. Because right now we're moving one whole cell, up to one whole cell per frame if we could. That's our maximum. We don't want to be we don't want to be frame based. We want to be, you can move this many pixels in this many in a second or in a minute or whatever. Come on, can I get to 25? Oh, so very disappointing. Just shy of 25. So I can get to one thing every 2 seconds, at least at the moment. And be hard pressed. It starts to hurt the tendons just a little bit. Yeah, I know, first world problems, right? But it's a good spot to be in. And now we'd like to have some things like, yeah, I know that there are 2 numbers up there on the side, and what are those numbers and why do I care? And so after this, after you watch this, we're going to come back and we're going to put some labels up there. So see you in a minute. Today's F# language feature of the day is record. Okay, doke, so we're here in our sandbox and we're going to talk a little bit about record. A record is a type. We make record types. So we're going to have the caps lock dot on. And we're going to type very common. I wind up with location is one of my types. So in my location type, I want x to be an int and I want y to be an int. And then perhaps I say let start equal x equals 0, y equals 0. And type inference correctly says, oh hey, that's a location. I know what to do with that. And so you have field names. So in declaring the type, and then very often the way I'll declare the type is like so. And I like to put one little extra space so that everything is nicely lined up. So you have whatever name you want and whatever type you want. You can even have other record types, and you very often will, because this a lot. But in the end, then you're going to say like let start x equals start dot x. Let start y equals start dot y. And this is because you can use a tuple for these sorts of things, something this simple. But once you get more than about 2 or 3 things, once we get past 3 things in a tuple, you get lost quickly. And records are a really great way to do it. Now, a record is immutable, so I can't go start.x is a value 10. Can't do that. That's going to go, I don't know what you're talking about. That's not mutable. You can, and it should stop complaining. Don't do that, generally speaking. Instead, well, not instead. Instead, you do things like let change location x, and then you have your location and your delta x. Now we've got a function, and this is how you change only part of it. You say location with x equal location dot x plus delta x. And typer inference figures it out. And this is way better. So rather than when I was first doing it, I would say, oh, well, x equals location at x, y equals location dot y. And it is possible to do it this way, but don't, because the whole idea of the width is I only want to see everything else is the same. Everything else in location is the same, just these things are different. And that's the whole point. You can reconstruct the whole thing from nothing if you want. But in addition, this gives the compiler the ability to go, oh, we'll just reuse where it's pointing to and not have to construct an entire object as long as things aren't mutable or whatever. And so that is a record type and pretty commonly how to use it. And my main point about records is this. A record is a thing that is a group of named things. Hey, we're back once again, and we're going to do some drawings. We know that we have 280 by whatever we want. So, I'm going to reverse these colors, and I'm going to paint a nice black background. I'm not too terribly concerned about how big the letters are. And time. And do I care what font I have today? There's Sigil marker. Score and time. You know what? This will do. These will do. And, step 1. Paste that into a new one. Step 2. This is very often how I do things of this nature. We're gonna go in. We're going to use the magic wand. We turn that there. We invert. Get down to that. Same thing there. Control I inverts, and then Control Shift X cuts it down to there. I then go with the canvas size and see where we're at. It's 84 by 84. That's not very much, but we want 280. And that's what we're gonna. Since it's currently left just 5, we're gonna leave it left justified. And we fill it in their spots with that. Same thing here. Canvas size. It's 280 by 26. This one, hold on. This one is 280 by 30. I think I want canvas size 280 by 36. We'll leave it like so. Gotta fill in the top and the bottom. 280 by 36. We're gonna go 280 by 36 here. Image, canvas size 280 36. And do that exactly the same way. We're gonna fill that in. And now we've got a score label and a time label. I'm going to save them off. Call it score label. Time label. And let's get that. Don't save. And who knows? We may need more. Okay, we're going to add existing items, content, time label, add those in. Don't forget their newer, and don't forget their content. Remember last time, copy of newer and their content. At this point, this part gets a whole lot easier because I just say, oh, I need here in my game, I got score label, time label, and I just put those. Oh yeah, score font. Just score label, time label, time label. And we have gotten myself to a point where I have something that's wider than the things, so making the vertical alignment takes a few minutes. Well, not a few minutes, it takes a few seconds at this point, but then later, if it were a lot larger, it would take even longer. But that's what I'm talking about. And you keep it neat and organized, and it's cool. But now those are at 30, so I need to make sure that in my draw seconds, in my draw score, I'm going to be at 30. And then my time label will be 30 plus the 28. Hey kids, you know what? Everything's 30 now. Let's make life simple. Everything is 30. So where's that? So that one's 30, and then we'll have the label at 60, and then so this will be at 90. And we'll also we're going to draw the score label and time label. And time label. Of course, 36 times board column is becoming the most copy-pasted thing in the whole application, and I'm not liking it. That's our candidate for let status panel X equal 36 times board state board columns, because I don't like it anymore. So it's a status panel X. So I do it once, and then henceforth you are status panel X. We will get you. We will eliminate redundancies. We will get the rest of these too. This is severe slop, but we're in some major flux right now. And do I build? I do build. Okay, it does not look great. I don't mind saying that, but we got a score, we got a time, and we can play a game. We can play one game. That's the thing. We can play one whole game, and then we're done. And that's no good at all. Okay. What we're going to need is a way of starting a new game when the game is over. No, I'm actually just playing the thing. Alright, see, but as you go along, it actually relatively quickly. This is most of the way through episode 5, and at the end of this episode, we will have a game that I would consider to be complete from the point of view of you can play a game from start to finish. It is not beautiful. It is not great, and it's a little fun, and because there's that little bit of time pressure. But it is complete in a game sense. And these are 45 minutes piece, more or less. And so, really I talk over, don't I? So I'll call it 50 minutes. 50 minutes times 5, and divided by 60. That's 4 hours. And plus, I blather on about things for at least one third, or 1/4 of that time. So say, 3 hours. You move around between tools, and there's a game. But okay, well, the thing that we need. Got drawing the game, and I've got updating the board state. So that one updates the play state. Alright. So I need to update the keyboard state there. Okay, so this gives me a keyboard loop, and I can say what is the function here? This is a board. Now, okay, so you can do it. If keyboard board state dot keyboard state dot is key up, keys dot F2, because F2 is start a new game, and board state, it's actually, and keyboard state dot is keyed down, keys F2, then do I have to indent else? I did that, then it's play state. Otherwise, it is game state, or it is game over state. Does this work? Well, yes, it does. So now board state's immutable, so this is good. So this illustrates an important concept in functional programming. The board state that I refer to here and here, even though this thing, even update keyboard state, has now made a new copy of board state and put keyboard state in it. but it's not a variable. It's not mutable. Board state is the same right here, and so this is avoiding side effects. This is like one of the big important things in functional programming is elimination of side effects. I don't have to worry about the fact that I did it in this order. I can do this way, and it will work, and we can prove it because we got a couple minutes left. But I'm gonna run down what's going. So we're grabbing the keyboard state, and we take the board state, we update the keyboard state because we do want to do that, and we say if our board state, which is not the board state that's been updated, has a keyboard state with the with F2. F2 has to be up, and then F2 is down. We're going to go over to play state. Otherwise, we're going to stay at game over state. Okay, let's see that in actual action, just in case I've completely, because I know I'm not wrong. Let's see. And also, we have one of the things we don't have is it doesn't clamp to the. It does not clamp to the screen because I can still go off even though I can come back on. So that's one other thing that we need to do. It doesn't make the game unplayable, but it does make it rather obnoxious to have to remember to stay on the playfield. And speaking of, that's one of those ding ding. Got to have some sort of sound effect going on, and I don't at the moment. So 22. All right, so yes, I get somewhere between 20 and 22. Let us do the thing where we clamp. We're gonna clamp his movement. So when we update the game state. Update play state, new board state, decrease time, move avatar. Where's the clamp avatar? We will clamp him. What does clamp mean? It's a texture term. Look up clamping. Look up texture clamping, and you'll get the sense of what I'm doing here. That clamp avatar board state equals. How to do? We want a new X and a new Y. We want it to be. So we got under board state. We've got board state dot board columns and board rows. Where'd my clamp go? So I want. Select clamped X equal. It's gonna get match board state. We will say board state dot well, let's get X. Okay, let's just do it. Let XY equal board state dot position player dot player. Oh, of course, base expression. So, we would normally return. Okay, so board state with. Okay, let clamped equal XY. And we'll do our operation there, and then we will return board state with player equal clamped. Okay, so even at the moment we're not doing anything. So, but now we can do something here, and this is warning non-idiomatic code. So match x with v when v less than 0, 0. V when v greater than equal to board state dot board columns. Board state dot board columns minus 1. Anything else? Anything else? X. Okay. Now, we can do this just like this in code. It is ugly. But board columns. What are you angry about? Oh, I don't have to do. I think I'm including, aren't I? Yeah, I got board state in here, so I just need board columns. Rows. Don't you like? Then that cannot be applied. Board columns minus 1. Are you happy now? I very often make so. A very strange use of match to do this, but it gets the job done and relatively clear. But this is going to be a huge area to clean up later. I want, like, here's always my class side. Hey, when x is a value where value is less than that, and but otherwise spit it out as x. Let's see if it works very quickly, and then we'll be done for the day. Okay, can't leave. Can't leave. Can't leave. So yeah, it is dirty. That's dirty code, and we'll fix that up another time. But it gets the job done. And very often it's like, hey, you got to find some way to get the job done, and you do, and then you go, here's the more idiomatic way to do it. But so that's where we are. And all right, let's review Trello right quick here. And did we do it? Did we get it done? We got a score label. Sure did. We'll leave it. We'll update it next. Well, no. Yeah, we'll update it next time. But do we get through there? We get through there. You see score time. I don't know about easy, but we did it. All right, great. We're now at a complete game. Did we check that the restart worked? I don't remember we did. Let's try one more. Let's look at one more time. We got a minute. Where is my how much time you get? Oh wait, did I even do anything yet? No, we're not done. We didn't get done. But it's okay. We'll get it next time. Because here we have a game over. It just moves it over to the play state, and that's not going to really do anything. It's going to immediately come back. So we're not done. We have the ability to switch back and forth, but it needs to actually reset the board, and we will get that next time. So we did not quite make it, but so it goes. And thanks so much for watching. The Joy of Functional Game Dev, Project 1, Episode 5.